Hello, Daniel here, and welcome to another AutoFlex Connect settings tutorial video. Today I'm going to be looking at the final mode in the misting and fogging, and that is the smart mode. So I'm going to hop into the settings here. You'll see I have a pump, two fans, and 3 misters that I have already configured here. If I wanted to change up the order of my misters, I could select them and use the arrows here, and they turn on top down. Like I said, today I am going to be talking about the smart mode, so I will select that here. Now I will just note, before I hop into things, the smart mode is the most complicated, and it's kind of a combination of the soaker mode and the misting and fogging mode, in that we have both our misting duration and our cycle duration changing as our temperature changes. There might be some confusion on misting versus cycle, so I'll just take a moment to explain how that works, how the durations of those work versus how much cooling you're getting, and then I will hop into explaining the rest of these general set points, and then we will just set up these specific set points. So for misting is the amount of time that your misters are on. So the more misting you have, the more time you have of adding water, which generally means more cooling. So the longer the misting, the more cooling you're getting. The cycle time, that is the total amount of time that each misting cycle has. Now, your cycle time can be longer than just your misting time multiplied by your number of misters. And that is because at the end, once all your misters have added their water to the atmosphere, then your fans will continue running and they will help to evaporate that water and cool things down. And so the cycle time is actually the opposite of the misting time, in that the longer the cycle is, the less often you're going to be doing misting, the less often you're going to be adding water. And again, generally speaking, the less you will be cooling. And so cycle time, the shorter the cycle time is, the more cooling you're getting. So as cooling increases, your misting duration will increase, your cycle duration will decrease. Now I will tell you how that all interacts with these set points up here, our low, high, and max set point. Now these can be thought of kind of like a variable fan, where it has the idle, the set point, and the differential. When the temperature is below the low set point, we are not going to be doing any misting at all. This is like on your variable fan. When you're below the idle set point, the fan is off. Between the low set point and the high set point, we're going to be doing a minimum amount of misting. So that means our misting duration is going to be minimum and our cycle duration is going to be maximum. So it's going to be as far apart and as short misting as possible. And this would be like your variable fan idling. Between the high set point and the max set point, we are going to be increasing the amount of cooling that we are doing. So between those, as the temperature rises, our misting duration is going to rise from our minimum to our maximum, and our cycle time is going to decrease from our maximum down to our minimum. And this is like our variable fan ramping up speed. And so once we hit the set point temperature, max set point temperature or higher, our variable speed fan would be at 100%. And so our cooling is at 100%, which means the most cooling possible, which means we are having the maximum misting duration and the shortest or the minimum cycle, which just means we're going to be misting more often and adding more cooling. So that is how these low set point, high set point, max set point, as well as our misting and cycle duration, kind of how they interact. And for this example, I'm just going to leave these set points here. Those are just fine. Active start and active end, those are pretty simple. If you don't want to be misting all day, if you only want a chunk of the day to be misting, or maybe you don't want to be misting overnight, you only want it to be during the day, then you can use these to set up the time where misting will be active. Right now I have it set 5 a.m. till 10:30 p.m. and that's just fine. I will just leave that. That's good for this example. Pump delay, that is the amount of seconds that we give our pump to pressurize our system before we turn on our first mister. When the control looks to decide, or when the control has decided that it is going to turn on because the temperature is, hot enough that it's saying turn on, the pump will turn on and the two fans will turn on, and then it's going to wait the pump delay, that amount of seconds, and then it's going to turn on the first mister. And it'll run for whatever our misting duration is, whatever the appropriate number is. And then that first mister will turn off. Then our second mister will run for the same duration, turn off. Third mister will run for that duration, turn off. Our pump turns off. And then our fans keep running until our cycle time is up. And then it reads the temperature again and decides, does it run another cooling cycle, or has the temperature dropped enough that we're okay? How this would operate when we are in our idle position, or our minimum misting, we would have 2.5 minutes of misting on each mister. And so that would be 7.5 total minutes of misting. And then we're running at our maximum cycle. So then that is 32.5 minutes of just the fans running. That is our minimum misting. Our maximum misting is going to be 5 minutes for each mister. So that's 15 minutes of misting. And then our cycle is only 20 minutes long. So then that's 5 minutes of just the fans at the end. And if we're somewhere in between the high set point and the max set point, it's going to be somewhere in between those numbers, but that's the way it will work. So that is smart mode. One final thing that I will talk about is the high humidity bypass settings. So if this is enabled, basically you can assign a humidity probe and set up a humidity set point. If the humidity is above this set point and the control is, the temperature is telling the control that it should run a cooling cycle, if the humidity is above the set point, it is not going to turn on the misters. It is only going to run the fans for that cooling cycle. And that is because we already have enough water in the air. We don't need to add more humidity. We just really need to add the extra ventilation from the fans and try and get that water that's already in the environment to evaporate to help cool things off. If the humidity is below this set point, then it will run a normal cooling cycle, run through all the misters, just like I explained before. I will save these settings, and that'll do it for this video. See you guys in the next one.